I could never be a YouTube personality. All right, a dilation is, it's basically, I'm just going to say, it's similar figures on a graph. Similar figures on a graph. So yesterday we talked about similar figures. They can be bigger, they can be smaller. It's the same shape, just a different size. This is that same idea, just on a graph. There's something called the center of dilation. You know how I said in art, y'all have that vanishing point where everything is kind of focused towards that one point? That's our center of dilation. Everything comes and goes off of that point. So it's our vanishing point. And for those that don't know what that means, for my non-art people, the vanishing point, you don't have to write this down. So when you draw, I don't know, there's always really popular ones are like the street that like disappears into the horizon. And so it like looks like this. And then you have the street. And then like you have buildings on the side of the street that, I'm not good at this, look like this. Stuff, that's terrible. I'm not good at this. I'm not an artist. You know what I'm talking about? Yeah. You've all seen pictures like this. Yes, it's going to get progressively smaller the closer it gets to this vanishing point. So if this is a tree on this side of the road, and this is a tree, and now this is that same tree, so it's all, everything is shrinking towards that one point. So if this was a graph, this is the vanishing point, this is a little triangle, it's a rectangle. So this would be a bigger rectangle. This would be an even bigger rectangle as it's getting further and further away from this vanishing point, and it would keep going forever. So out here you'd have a really huge rectangle and so on. Does that explain vanishing point? Center of dilation. Everything is coming off of that point. So, I need a new color. If you had a little graph, just so that you have a visual in your notes, I'm just going to do positives. Your original triangle could look like this. Make it a nice little right triangle. Your original triangle, your OG triangle, we're going to call it ABC. Now, if I used this origin as my center of dilation, it does not have to be the origin. Everything comes and goes off of this dot. Second period got mad at me because I used a ruler, but I keep my notes forever and I don't want it to look bad. So if I go through 0, 0, and I go through dot A, come on notes. So it's going to look kind of like this. And then I come off point C, go through the origin, or the center of dilation, and through point C, and then again through point B. Have y'all ever done something like this in art?
Yeah.
Okay. So y'all totally get what I'm about to do. And you do the same thing. All right. These 3 lines show me where my new triangles would be and what points they would hit. So if I take this line and I move it up the graph out here, it would be the same exact angle. So it would stay this angle, but I would move it out here, so it would stretch from here all the way to there. So this line would then become this line, and then go straight down, hit that line, and then straight over and hit that line. So same triangle, just blown up. It's, oh wait, I messed up. See, dang it. It hits that line, sorry. Then hits that line. Man, I was doing such a good job. So you have to hit each 3 lines. 1, 2, 3. Yes?
So, it's kind of like what we learned yesterday about
Yep.
how it's the same thing as the
Yep. We're just putting that on a graph. Now our new triangle, so we had ABC. New triangle gets a little apostrophe to show that it's the different one. We've done something to this to make it bigger or smaller. So it's A prime, B prime, C prime. It gets a little apostrophe. So the originals don't have an apostrophe. The changed ones have an apostrophe. So you know the difference. Original, new. And if I kept those lines going forever, every triangle that you just stretch it along those lines, as long as the angles stay the same, it fits, yeah. You just have to keep the same angles. Okay? All right. Another vocab word. I need new pens. Scale factor. I just remembered that I have a ton of pens behind me. Scale factor. So scale factor is how much, it's like if you gave a number value to how much you changed it. So if you doubled the size, scale factor is 2. Yes?
Can we make an arrow saying that new blue triangle is new?
Yes. Okay. Please do. Oh yeah, original, so this would be new. Thank you. So scale factor is amount of change. If it's an enlargement, then your scale factor is greater than 1. So if like you double the size, that's a 2. Triple the size, it's 3. Quadruple is 4. If it's a reduction, it's less than 1. So if you took half the size, it gets smaller. A fifth of the size. A tenth of the size. Now, for the actual number part, because it's there, but it's not that crazy. If you have triangle A, B, C, and this is where dilations and similar figures kind of differ, because they're going to give you coordinates for things. So if point A is at 8, 2. Point B is at 8, 6. Point C is at 2, 4. That's the original. And then I changed them. A prime is at 4, 1. B is at 4, 3. And C is at 1, 2. Now, just looking at A from the old or from the original to the new, can you see something that stands out? Yes. What's up? What do you see?
Got divided by 2.
Divided by 2. Now, if I were to put a value of dividing by 2, what is that number? 0.5, which is half. So this was halved to here. So our scale factor is half. Not that y'all have to know that yet, but it's nice to be able to do it. Because 8 divided by 2 is 4, or half of 8 is 4, half of 2 is 1. So this triangle, the lengths are half the size of this one.